Okay, so the next question that we have on the menu today is presenting the situation where we have two identical ions. So those are just charged items. So the electrostatic force between two identical ions that are separated by 5 times 10 to the negative 10 meters is 3.7 times 10 to the negative 9 newtons. Now we have to find out what is the charge of each ion, how many electrons are missing from each ion, and how far apart must two protons be so that their electrical force, their repulsive force, is equivalent to gravity on Earth's surface. Okay, so let's handle this question one at a time, 1 point at a time. Okay, so the first part of the question is presenting this situation. We have two ions, so we got a charge Q here and a charge Q here. We know that their separation distance is 5.0 times 10 to the negative 10 meters, pretty close together. And they have a force, let's make a blue force. The force that they feel is going to be like this. Identical ions means that they are going to be repulsive because that's why they're trying to get away from each other. If they were opposite charges, they would be trying to get closer to each other. But the key thing here, identical ions. So they have to have a repulsive force between them. Okay, and the force of this is equal to 3.7. Whoa, let's not scroll down like that. 3.7 times 10 to the negative 9 newtons. Cool. Okay, so what we're trying to do is we're trying to solve for the charge on each ion. And let's get back to my black pen here. We know that Fe is equal to Kq times Q over R squared. In this case, Q's are the same. But we're trying to solve for the Q. Okay, so in this case it's Kq squared over R squared. So we just got to isolate for the Q. So that's going to be Fe times R squared over K, all under the root, is going to give us RQ. Okay, let's sub in these numbers. By the way, K is equal to 9 times 10 to the 9. That's Coulomb's constant. It's a good thing to keep in your mind. Okay, so let's sub in our numbers. 3.7 times 10 to the negative 9 times our distance of separation. So that's 5 times 10 to the negative 10, but all squared. All divided by 9 times 10 to the 9. And that's all under the root. Cool, so I'm going to pull out my calculator and figure out what this calculation is. So we got 3.7 times 10 to the power of negative 9 times 5 times 10 to the power of negative 10, and that's squared, and then divided by 9 times 10 to the power of 9, and that is divided out. And the result of this whole thing is under the root. So, okay, so my calculation for the charge Q is 3.205. We only got two significant figures, so that's what I'll need to leave it as. 3.2 times 10 to the negative 19 coulombs. Okay, so this will be the charge of ions. Okay, and then the next part of the question, well, that's part A. Part B of the question is how many electrons are missing from each ion? Okay, so if this is the charge between them, we know that the charge of an electron charge, This is 1.6, or negative that is, but let's just keep it as absolute value. So positive, or maybe, but just better not to write that at all if we're doing absolute value. Oops. Let's get my pen back. 1.6 times 10 to the negative 19 coulombs. So since that these are charge is double electron charge, must be 2 electrons. 2 electrons missing, that is, or 2 electrons gained. All right, so there could be 2 electrons missing. There could also be negative 2 electrons missing, because you know we have some like metals like to lose electrons, and you know, things that are closer to the right side of the periodic table, they tend to gain electrons. Okay, so it must be 2 electrons away from neutral. Okay, we don't know if they're gained or lost. Okay, so that's just a little bit of chemistry. It's not necessarily mandatory. I'm sure if you said 2, you'd be fine just there. Okay, the next part of the question is, how far must 2 protons be if the electrical repulsive force acting on them is equal to its weight on the Earth's surface? So, okay, so this is what question 3 is asking us, or part C of this question, is pretty much the force of gravity on a proton is going to be equal to the electrical force of repulsion between 2 protons. Okay, so we know that the gravitational force is just mass times the acceleration due to gravity, and this is going to be q squared. We have 2 protons, they're clones of each other, they're going to have the same charge, over r squared. Okay, so it's asking us what is the distance between them for this to be possible. So we're pretty much trying to solve for r. So r squared is equal to kq squared over mg. And r is going to be, well, we send that all under the root, kq squared over mg. Now the mass, to sub in these numbers, we know that k is going to be 9 times 10 to the 9, nice and easy. Q is going to be the charge of a proton, which is the exact same as the charge of an electron, so 1.6 times 10 to the negative 19 coulombs. The mass of a proton, if I remember correctly, is 1.27 times 10 to the negative 27. I think. 1.67. Ah, so close. Negative 27 kilograms. And the acceleration due to gravity, that is 9.8 meters per second squared. 9.81 meters per second squared. Okay, so subbing all of these into our equation, we will get a situation like this. R is equal to, under the root, we have k, 9 times 10 to the 9, multiplied by q squared, 1.6 times 10 to the negative 19, all squared, divided by mass, 1.67 times 10 to the negative 27, multiplied by gravity on the downstairs, 9.81. Okay, so let's calculate this out, see what we get. So on the upstairs, we got 9 times 10 to the power 9 times 1.6 times 10 to the power negative 19 squared, divide by 1.67 times 10 to the power of negative 27 times 9.81. Actually, divide by 9.81. And all of that under the root. And my calculation for R is 0.118 meters. Okay, hopefully we found a similar result here. Exactly. Cool. So this would be the separation that would be required for that. Awesome. So yeah. Yeah, that addresses all of the points of interest of this question. So we can call that a question complete. Awesome. Big high five.